unit is about. Okay? All right, so here we go. We get to 1.3. You're going to get an assignment today, but you're not going to get an assignment tomorrow. We will not finish today's notes. We'll have 2 problems we need to finish for tomorrow, and so you'll be given about 35 minutes tomorrow in class to work on an assignment. Do you understand that? Today's assignment will be lengthy, but you will not have one tomorrow, and you're going to be given lots of time in tomorrow class to work on. Do you understand that? Because I need to see how you can handle the information, because I just don't know you well enough yet. So we start with the easy stuff. I know you can do this. Okay, perform the indicated operation. The indicated operation is addition. So in this situation, just combine like terms. 8x squared minus 8x minus 14. No big deal, right? What about the one below it? What do I do first there? Distribute. So I have negative 6x squared plus 3x minus 9. Oh, no. What do I do now? A negative 4. Okay, not a positive 4, but a negative 4. So minus 16x squared plus 20x minus 4. There we have it. Did I make a mistake? Okay. How about letter E? If I were to do the problem incorrectly, what would I do? Incorrectly, what would I do? That's a very common answer I get if I ask this question on a test. Instead, we're going to do 3x minus 4 times 3x minus 4. There I have 9x squared minus 12x plus 16. Or 9x squared minus 24x plus 16. We all okay with that? Letter B, a lot of people remember this as FOIL, first, outside, inside, last. But really, when we're multiplying any polynomials together, the whole idea is take each term of one and multiply it by each term of the other. So you don't have to think of FOIL. We have a plus 28x, a minus 4x, and a minus 14. So combine like terms, I have 8x squared plus 24x minus 14. And there we have it. Let's try F first, because D looks really difficult. F, we're going to distribute. Negative 10, x to the 5th, minus 6, x to the 4th, plus 2, x cubed. Now, can I show what people do from here? People say, oh, I can take out a 2x cubed. Or even a negative 2x cubed. If I do that, I get, let's see, that's going to be 5x squared. That would be a 3x, and that would be a negative 1. Well, that's what I started with, right? I'm not surprised you could come up with it again. But people are like, well, I don't know what I'm supposed to do. Well, it says perform the indicated operation. What is the operation here? Just distribute multiplication all the way through. If it said factor, well, it already is factored, okay? So some people say, well, when do I know when to stop? Well, that's part of understanding the language of mathematics, okay? Kind of like in this situation, people would say, oh, well, I can factor that to 3x minus 4 times 3x minus 4. Well, yeah, that's what I have right here. Or they may even say, oh, and the answer is 4/3. The answer is 4/3. There's no answer. There's no equal sign. There's no solution, right? So just understand what we're asking for in those expressions. Now, I'm going to try to be nice and not take off points. If you like if you go on the test and you do this, I'll probably circle this. I'll maybe say -1/2, or I might just put smiley face and not take anything off. But just, hey, come on. Let's stop, guys. So let's look at D. Well, D looks challenging. Where do you even start? Distribute. So how do you take x to the 3/2 times 2 roots of x? Okay, so we want to change this to a radical. How about we do the opposite? How about we change that to a rational exponent? You guys remember how to do that? If I have 7/4 roots of x cubed, I can switch this to what we call rational exponent form. So that's 7x, and I still keep the cube, but I put the index in the denominator. The index goes to the denominator. Do you remember that? You maybe didn't cover it a lot, but you should have covered it a little, okay? It goes to the denominator. So I have x to the 3/2 times 2x to the 1/2 minus 3x to the 5/2. Well, now it's a very easy problem, isn't it? I just add the exponents. 3/2 plus 1/2 is 4/2, which is 2. And 3/2 plus 5/2 is 8/2, which is 4. So we took what looked like a challenging problem and made it quite easy by changing the radicals to rational exponents. That's something you need to feel comfortable doing. Are we all clear? Okay. All right, flip it over. Let's review some factoring methods, and we'll do so rather quickly. First of all, we start with greatest common factor. Greatest common factor here is 2x squared. I take it out, and I'm left with 2x minus 3. You go ahead and do a greatest common factor for letter B. Now, if somebody did this problem incorrectly, what might they do mistakenly? What might they do? Yeah, they missed the 1. Okay, very common to miss the 1. The nice thing about math is you can always verify if your answer is correct. So on the test, I would make sure that you distribute that back through. 9y to the 4th, 3y minus 12y squared. If you don't come up with the same expression, then something's wrong. Okay? Something's wrong. All right? So, let's move on. We have trinomial with leading coefficient of 1. That means that you don't have a coefficient out front other than that 1 on the x squared. So I have two sets of parentheses. It factors to two binomials, x and x. I'm looking for the two numbers that multiply negative 33 that add a negative 8. Yeah, could I do this instead of a minus 11 and plus 3? Could I do a plus 3 and minus 11? Yep, multiplication's commutative, so you can switch the terms that are the same. Could I do a minus 3 and a plus 11? No, then that wouldn't be right, would it? Okay. So how about this one? What two numbers multiply to negative 48 but add a negative 13? Yeah, so this one's a tough one for a lot of people. 16 and 3 is what we're going for. Is the 16 going to be positive or negative? Negative. Now it gets a little bit more confusing. If the lead coefficient is not 1, then what do? Well, there's a lot of different ways. Most commonly, you'd see something like this. And we have two methods. We could go guess and check. Or we could do the AC method. And I'll do both so that you can see how it works out. I'm a big fan of guess and check. That's just what I always did. I didn't even know the AC method until I started teaching, and another teacher showed me. And then I said, do you know why it works? And they're like, no. And I said, well, should we really do it if we don't know why it works? But anyway, that's another conversation. So I like 4x and 2x here because I got to come up with 10 in the middle. Now, if I put a 3 here, that would make 12. That's way too big. So I'll have to put a 1 here, and I'll try the 3 there. Do you know how we check to see if it's right? Yeah, we actually multiply it out. But when you think of FOIL, the first ones, we've already done those. And the last ones, we've already done those. So really, we got to focus on the inside and the outside. The inside is 6x. The outside is 4x. That makes 10x. So I'm good to go. Now, do you remember the AC method? So I'll show you. It's kind of cool. It's called AC method because we have ax squared plus bx plus c. And if you take a times c, so 8 times 3, we get x squared plus 10x plus 24. So let's factor that. What two numbers multiply 24 that add to 10? So I have x plus 6 and I have x plus 4. I leave a little space in front of my x's because notice x times x does not give me 8x squared, does it? So I'm going to have to put something there. So I put the 8 back in. Is there a common factor between 8 and 6? Is there something that divides into them evenly? 2. So take the 2 out, and you're left with 4x plus 3. Is there something that factors into 8x and 4 evenly? 4. Take it out, you're left with 2x plus 1. And you can see that it's factored correctly. So that's the AC method. You multiply the a by the c, you factor it, put the lead coefficient back in, and reduce. Nope, it just disappears. If you want to know why, come see me someday after school and we'll teach you why the AC method works. So, otherwise, it just seems like magic. Why don't you try F on your own? Either you do guess and check or go ahead and do the AC method, either one. I'm doing the AC method just for teaching purposes right now. I factored it to x plus 8 and x minus 1. I put the 2 back in. Is there a common factor with 2x minus 1? No, so I leave it. Is there a common factor here? Yeah, 2, so I take it out and I'm left with that. That's factored correctly. Not too bad? Okay, how about difference in two squares? How do we factor that? How do we factor letter G? Yeah, so we got 3x and y squared. Why does that work out so nicely? Yeah, it's 0 in the middle. And right now you see that we have positive, and then we have negative of the same thing, so we always give you 0 in the middle. How about H? Okay. Whoop. Oh, it factors again? Which one? Does the first one factor? Does it factor to x plus 1 times x plus 1? Why? Yeah. So here's part of how you know that it won't factor, okay? I'll give a graphical argument really quick for you. If you have x squared minus 1, if you were to graph y equals x squared minus 1, what does that shape look like? Starts with a P, parabola. And it's shifted down 1 unit, right? Does it cross the x-axis? Yeah, it crosses at -1 and +1. That makes a parabola, but it's shifted up 1 unit. Does that cross the x-axis? No, so you know it's not going to have any real numbers as solutions. Okay, so kind of helps you think of it, why it works, why it doesn't. Okay, we move along to difference of cubes. I'll pause my video and I'll go to the board. So let's try it. X cubed minus 8. What's the cubed root of x cubed? Cube root of 8. So x minus 2, square the front, square the back, multiply 2 together, and switch the sign. Kind of nice, huh? I mean, you saw that last year, right? But you maybe thought, ooh, that's kind of difficult to remember the formula. No, the formula's not too bad. Cube root. And y squared. What goes first? Square the front. Square the back. Multiply the 2 together. And good. Flip it over. We do 2 more problems. Tomorrow we'll do the tougher factoring, letters M and N. Okay. We do grouping. So review of grouping. Right now, what's the value of that negative 5? I just said it. What's the value of the 5? Is it positive or negative? It's negative. If I do this, what's now the value of the 5? Positive. So I've just changed the value of that by putting parentheses down. So you can't put parentheses down in front of negatives. So instead I write it as x cubed plus 5x squared plus negative x minus 5. Now I can put parentheses down because the value of that 5 is still negative. What do you take out of the first set? And you're left with x plus 5. What do you take out of the second set? Negative 1, you're left with x plus 5. Now, we just used a greatest common factor method for 2 different parts, right? We're going to do greatest common factor again. I have 2 terms. What do these 2 terms share in common? If you remove that, I'm left with I can factor that. X plus 5, x plus 1, x minus 1. You try letter L on your own. Try letter L on your own. So when I first did this problem, I started by taking an x out at the very beginning. But First Hour did the problem, and they grouped it, and then they said they took the x out at the end. It doesn't matter when you do it, so long as you do not leave your answer as this, because it's not completely factored. Now it is completely factored. Is that all right? Are we okay? So here's the deal. Do you, to stay on pace, do you need to complete the assignment tonight? No. You have time in class tomorrow. I know it's lengthy, which is why I'm giving you time in class. Okay? So a lot of times if you get a lengthier assignment, I'll give you some time to work on it and be able to ask questions. So if you'd like to write the assignment down, here you go. Never mind the eigenvalues reference. That's for somebody else. One of my former students is taking linear algebra right now, and I told her look forward to the eigenvalues. She has no idea what I'm talking about yet. That's okay. Few math majors out there. Jack Boondorf, but Darren Gildner. Jake Ware's, both his brothers were math majors, Sam and Isaac, and Sam Moyer, math major. Matt Tate, math major. Skylar Hansen, if you guys remember Skylar, math major. Lots of math majors out there. It's kind of the new fad. What do you say, Jessica? Natalie going to be a math major? Is she really? She changed her major to a math major. All right, will you tell her I said hi and that I'd love for her to come back and visit and tell me all about her math classes? All right, there you go. If you want to get to work, go ahead.